This is a summary of the 5 key aspects we will look at in this module. We will cover each element of the picture in the sequence shown, starting with the relevance of size estimates in projects. We will cover some key points regarding the relevance of size estimates here. Size estimates drive your project effort, which in turn drives schedule and cost commitments to your customer. If you have not used size estimates much, are you wondering why you should learn about it now? You may have encountered situations of having to provide a high-level estimate at short notice to respond to a request for bid, haven't you? If you responded using other approaches, such as a high-level WBS, the estimates would often turn out to be more guesswork and not based on how big or small the required solution is. In such situations, it is more reliable to develop a size estimate. If your organization has pursued a size-based estimation approach, you would have internal past data to validate your size and effort estimates versus other similar projects in the past. Even if you do not have such past data available in the organization, there's plenty of industry data on size estimates and typical methods, guidelines on how to translate them to effort estimates. So, in summary, with the size estimate as the basis, your bid becomes that much more reliable and defensible. While size is essential for a quick top-down estimate, it is by no means the answer for a detailed estimate and task breakdown when it comes to planning a project after you have won the bid. This is where you would adopt a WBS-based bottoms-up estimate. Of course, the bottoms-up estimate and the earlier size-based top-down estimate need to be reconciled. The other major benefit is the use of size estimate as a tracking or control measure. For instance, size can be re-estimated from time to time to check if project requirements are growing in size relative to the time of project start. Size estimates are also very useful at critical milestones. For example, at phase ends, to reassess and replan the subsequent phases. Hope you have understood the relevance and applicability of size estimates. We have talked a lot about size so far, but what exactly is size in a software context? Size makes it possible to measure how big a work product is in a project using some consistent measures. For example, it could be the number of functions or features you are trying to deliver in a product release. If you are using object-oriented approaches, it may have to do with the number of objects and methods the software comprises of. If you use use cases to describe functionality, you could measure size using use case points. Given that different functions or objects or use cases have different levels of complexity and deliver different value to the users, you would need to assign some weights to each of them. So what you get overall as size is a weighted count that we typically call function points or use case points or object points. If you're working on supporting an application, you measure the size of your support activity by the number of incidents or defects you need to deal with. For folks working on documentation, it may have to do with the quantum of documents they need to create in some measurable form. And for folks in testing, the size of their activity may be measured by the number of test cases they generate or run. The key message when we talk of size measures is relating to measuring the bigness of the output the team is producing. So whether it is function points, lines of code, or number of test cases, all of them measure how big the product or work product the concerned team is producing. Hope you get the point. When we talk of size estimates, there are two broad types of estimates that are used in the software industry. One is called absolute estimates. Absolute estimates are associated with the unit. To give you a real-life example, we talk about distance in meters or the weight of an object in kilograms or pounds. From a software context, lines of code, function points, use case points, etc. are all absolute measures because they are specific and uniformly understood units. On the other hand, relative measures are unitless and describe and rank one item with respect to other items in the same class. For example, how big a feature is relative to other features, or how complex or difficult a defect is to fix relative to others. You probably use relative measures in your support projects where you classify defects based on their complexity and use a number of simple, average, and complex defects to estimate your effort and staffing needs. Similarly, if you're using user stories to describe your functionality, you could use story points for sizing. Story points are numbers assigned to user stories based on their relative size and complexity. In this case, typically a story is taken as a base story and assigned a number, such as 3 or 5, and other stories are assigned sizes based on a comparison of their size and complexity relative to the base story. The most commonly used number series for assigning such numbers is the Fibonacci series that most of you may be familiar with. This slide presents an extremely important concept in terms of how you apply size estimation to different kinds of projects you encounter. Custom development is perhaps a simple category in this case. If you are developing an application, you can perhaps measure its size using function points. Alternately, you could use bottom-up sizing using lines of code if you can break the product into lower level modules or functions. Fairly straightforward, right? Application support projects typically project number of incidents or defects based on past data and other projections that you need to resolve as a primary size measure, and use some classification in terms of levels of difficulty or complexity to assign weightages to them to get a weighted count. Testing projects could use function points of the application being tested as a measure. However, if the scope of testing is known, then sizing can be done using a number of test cases to complete that scope. In a re-engineering situation, there's already an existing application or system and its size is known in terms of lines of code or even function points. You only need to estimate effort and cost using some productivity data. As a final case of project type, let's discuss the case of package implementation, such as customizing and implementing Siebel in your customer organization. What is the size estimate in such a situation? Do you really need to estimate size? Very valid question, since package implementation involves different kinds of activities, such as business process mapping or re-engineering, customizing the package for specific needs, training users, data migration, deployment across multiple locations, and so on. How do you define size in such a case, where there is a mix of different types of activities? One possible approach in this case is to analyze each one of the types of activities and size them separately, and then convert to an appropriate effort. Size estimates serve a variety of uses in a project as well as in an organizational context. We have already talked about their use in estimating effort and cost for a project. In addition to that, absolute estimates such as function points are also used as a normalization factor for comparison. For example, you could compare number of function points of an application developed for .NET deployment with a similar number for deployment in a J2EE environment. Or you could compare development productivity of one department in your organization with another in terms of number of function points developed per person month of effort. Often defect rates are normalized to size, such as defects per function point or defects per KLOC. And this data, for example, can be compared across successive product releases to see if product quality is improving. There is a host of additional analysis that are possible. We can talk of rate of change of an application in terms of function points or lines of code changed, release to release, or year on year, and so on. Similar analysis is also possible with respect to costs of maintaining an application based on size and size growth, effectiveness of quality control with respect to similar parameters, and so on. Organizational productivity data is often based on size and can be classified based on nature of application, development platform, team experience, and a host of other parameters as well. Finally, your quality management group would be a good source of contact for you to understand and appreciate how size can be used in a variety of different ways. This is a recap of key aspects we have discussed as part of introducing you to size estimation in a software context.